Hello, my name is Marquez Arroyo, and this is my presentation for my final motors project. A brief overview of what this presentation is going to entail. First, I will go through my overall diagram of the project, and then I'll go over the video of the project actually working. I'll talk a little bit about the performance of the motor. I'll then show and explain my electromagnetic diagrams and also my CAD drawings. Lastly, we'll go over a couple pictures of my motor, talk about my experience building the motor, um, things that I liked, things that I didn't like, and then go over the acknowledgements of people who helped me do my project this semester. Here's an overall diagram, a picture, an exploded view and an assembly view of my project. You can see we have the 4 parts here that I've made in my Fusion 360. We have 2 end caps, the rotor and the stator. These colors that I've chosen are the actual colors that they were when I printed them out. So that's why they have these different colors. Here's a quick video of here's my motor. I don't know if you can see it right there. And we're gonna hit the ball. So we'll see that. Watch it one more time. This video was taken in my apartment by Bagner Lopez, my roommate. Let's watch it one more time. And can't really see my eyeglasses, but I've got them on. Gotta make sure it's safe. Let's go to the next slide. So the motor was about 2.5 pounds, and on my farthest hit, I hit it about 5 feet. For the most part, it was not hitting it that far. I would say it was usually around 3.5 feet. I got 5 feet on one of my tries. It would have been able to go farther if we could have multiple revolutions, but we had a standard 1 revolution. So yeah, I hit it 5 feet. Here's my electromagnetic diagram of how the motor actually works. So if you look, you have the rotor here, and then these are like the coils. So it comes on each side of it and wraps around and connects to, this is the commutator on the outside. And here's the positive part of the brush and the negative part of the brush and the north and south poles. You can see here that the current comes into this side and goes around and out and through back to the negative side of the brush. If we use our right-hand rule, we can see that because of the way that the current is going and the magnetic field from north to south, that we generate forces in this way, spinning it clockwise. Here is basically the same diagram, except for you see this time there's 2 pieces of the commutator section touching on each side, here and here. So you have 2 pieces of the commutator section touching on the positive side and 2 parts of the commutator touching on the negative side. The reason I showed this was to show that even when you have both of them touching at the same time, you don't have any stall. Like there's no dead zones really on my motor, because even when all 4 of these are active, it still creates force in the same direction. So that's good. Here is my CAD drawing of my overall project. So you can see this is the assembled view here. And all of these measurements here are taken in millimeters, but the project ended up being exactly 5 inches by 5 inches, which is the maximum amount of space we were able to take up with our project. And I wanted to make mine as big as possible, hopefully uh, make it more powerful. Here's some pictures of the motor actually made and assembled. You can see on the left here, this end cap view, and you can kind of see some of the wiring that I had to do. But here you can see the brushes that I was talking about earlier, right here and right here, and the commutator sections that I had to short out and solder by myself. And then you can see more of the wires here that I had to wind. I ended up doing about, I think it was 75 reps for each coil. So it was a little bit less than I expected. I was hoping to get to 100, but 75 was good. Let's talk about my overall experience with the project for a little bit. Overall, I had a very positive experience. I would say that it was really useful to be able to build it and like have that firsthand knowledge of learning how to actually build it and how to design it. And through that, I think like if I were to be able to do it again, I would be able to make the same project one much quicker. It wouldn't take the whole semester. And also, I think I'd be able to make it much better than before, just given some of the struggles that I had to go through throughout the semester. SolidWorks versus Fusion 360. I have a Mac computer, so my experience was a little bit different. I had to learn how to use Fusion 360, which was not that hard actually. I think that most of those programs tend to be pretty self-explanatory, but I did have to get some help on YouTube and from my friend Moises a couple of times, who was also running Fusion 360. 3D printer. Everybody in the class got a 3D printer, and it was a little bit rough working on it sometimes, and that was a thing that I had to learn more about. That was one of the biggest struggles that I had, and I ended up utilizing the makerspace a lot and printing there. So that was a very useful thing for me. Yeah, and so some acknowledgements. I want to acknowledge Mr. Clyett, who's my lab teacher. He helped me a lot with kind of nailing down some of the measurements and the dimensions that I want for specific parts of my project. I want to thank Mr. Cheng Su. He was really there for me the whole semester and has been really my whole time here at CMA, encouraging me to do better. So I appreciate that. I want to thank Aaron Cole in the makerspace, helping me print, teaching me more about 3D printing. That was very much appreciated. I would like to thank Moises Farias. Taught me a lot about Fusion 360, as I said earlier, and was just a good person to ask questions to. And lastly, Wagner Lopez, my roommate. I want to thank him. He took the class before and had a lot of useful information for me throughout this project. So yeah, that's my video. Thank you for watching.